YOLO guys! So this is skill 3 to catch the monster Trigonometry Jr. Now we call this one coterminal angle, related acute angle, and a Kest rule. So there are 3 skills and you really have to pay attention to these. These can be confusing but they are quite easy. So time to time what I'm going to do is I may call this related acute angle as a Ra. Okay, not the Egyptian god of the sun.
이 뭔 개소리야!
So let's take a look at the coterminal. Now, co means together, and terminal means coterminal here means terminal together.
Wow!
So let's take a look at terminology of what we're dealing with here first, and then take a look at the coterminal angle. So before we begin, for the quadrants, we actually go from counterclockwise. So we start from quadrant 1. That's because both x and y are positive. And then we change the x first because it comes first in the alphabetical order. So we go to the section or quadrant where x's value changes to negative. And then we change the y value from there. So then both are negative, we call it quadrant 3, and then the last one is just quadrant 4. So we rotate from the first quadrant, where the top right corner, in a counterclockwise. Okay, so remember it is counterclockwise. Now coming back to this one, so I just drew a circle and put an arm and I'm making a triangle inscribed. So here, so this green line that I just highlighted is called terminal arm. Basically, that's where your rotation ends. Remember, terminal means end. For the terminal arm, I'll just put the highlighter down here, and it's called the terminal arm. Then the next one is where it starts. I mean, where if there is something that ends, then there's got to be something that starts too. So this is where it starts all the time, and that we call initial arm. Then the next one is the angle over here, the rotational angle from the initial arm to the terminal arm. So that angle, we call it a rotational angle. So as I said in the beginning, coterminal means terminal together. So coterminal angle is where the terminal angle rotates and comes back to where it was. If you take a look at that, that means my terminal arm or the rotational angle can rotate infinite number of times in a counterclockwise, right? 1, 2, 3, and on and on and on and on.
What?
A few moments later.
And we know that one revolution is 360 degrees. So let's take a look at this. If I rotate this arm once more, and I can simply come back to the same terminal arm as the previous one. So this one is then the coterminal angle of the pink angle. The easiest way to find the coterminal is just rotate it. Rotate it one full revolution or 2 or 3 depending on the question. If the question says find anything between whatever the angle and whatever the angle, you basically follow that. So the coterminal angle, you can simply find theta plus 1 revolution, which is 360. Again, the theta is the angle of rotation. Now, then if you think of the other way around, for another coterminal, we can go backwards. If we go backwards, and then we will come back to this. But again, instead of going counterclockwise, we just went clockwise. So then we call this negative direction, so negative angle. So another way then is our theta subtracting the revolution. However, remember, these revolutions can go as many as you want depending on the question. So all you have to do as a final formula is one positive coterminal angle is theta plus 360 times the number of revolutions. Another one is then the negative. So then it is the theta subtracting 360, the one revolution, times number of revolutions. This is confusing concept. So make sure you do understand this. If you don't, leave a comment below, then I will answer them. So let's take a look at the first NPC. It says, find the coterminal angle of 45 degrees from negative 360 to 360. What it means is then think of this way. If I have a circle and I will rotate it, now my 45 degrees is somewhere over there. So that is my 45 degrees. And I do need to find the coterminal of 45. So then I have to rotate clockwise and then I come over there. 45 is theta plus 360, which is then 405 degrees. The other way is then 45. You go backwards going that way. Therefore, then subtract 360 from it, and that becomes negative 315 degrees. However, we say it's from 360 to negative 360. Therefore, we can only accept the answer that falls under this. Therefore, we cannot accept 405 degrees. We can only accept negative 315 since 405 degrees is above 360 degrees. The next one is related related acute angle, I call it RAA or RAA. So this is basically the acute angles inside of a triangle, inside of the unit circle that you usually deal with. They actually are very useful when you're looking for different angles that gives the same ratio for each sine, cosine, and tangent. And finding the RAA is actually very simple. So let's take a look at it. And as you can see from the name itself, it says acute. So it's the angle inside of the triangle, not the right angle. It's the one of the two acute angles. When you are looking for these, the easiest way that I can find is drawing a bow tie. So for me, I draw a bow tie using this first triangle, and it will look like this. So here's the bow tie, right? Well, it's not really the accurate bow tie since this point, this one should be at the origin, but let's just ignore that for now. Now, the acute angle that we have, or the rotational angle, is this theta. Then all the related acute angles are the angles that the triangle or the terminal arm makes with the x-axis. So these angles that I put theta, they are all equal to the original angle, obviously, inside of this triangle. Therefore, these are the related acute angle. They are not the same rotational angle, however, they are related to the acute angle that the terminal arm is making with the x-axis. So if this is, for example, 60 degrees like the NPC2 says, then this one will also be 60 degrees, this one will also be 60 degrees, and the 60 degrees as well. So to find then the actual rotational angle for these is then the first one is all the way to the second quadrant terminal arm, which is 60 degrees less from 180, right? So that is a 60 degrees less from 180. Therefore, the first one is then 180 subtracting 60. This is the second quadrant, which is 120. Then the next one is the one in the third quadrant right there, which is now then 60 degrees more than 180 degrees. So the third quadrant is then 180 degrees plus 60 degree, which is then 240 degrees. Then the last one, as you can see, is in the fourth quadrant, and that one is 60 degrees less from the 360 degrees. Therefore, 360 subtracting 60 degrees, which is then 300 degrees, right? And if you go more than the one revolution, that is a 60 degrees more from the 360, so you just add 360 to the 60 degrees. So hopefully you can see that the angles that you're using to subtract or add to is 180 or 360 only. You don't use 270 or 90 because you're dealing with the angles from the x-axis only, not the y-axis. And the x-axis is the horizontal axis, which represents either the half circle or the full circle, which means then 180 degrees or 360 degrees. Hopefully this was helpful. Hopefully this was easy enough. You will see why this is so useful in the next MPC. So hopefully the coterminal angle and the related acute angle seem easy to you. Hopefully you understood the whole concept. Thanks for watching. Please don't forget to hit the subscribe and the like button. The other part, the Kest rule, I will explain in the next video. Please watch it because it is very important for your trigonometric function junior as well as a senior later on. Okay, bye bye.